Alright, so today we're going to talk about multiplying matrices. This does get a little more complicated, but I'm also going to show you how to do this in your calculator. So we're going to do it by hand, and then I'll show you your calculator. You can decide which way you want to do it. Either is fine. You do need to know how to do it by hand, though. Matrices A and B can be multiplied if and only if the number of columns in A equals the number of rows in B. Okay, so we can multiply only if the columns in A is equal to the number of rows in B. If matrix A has dimensions m by n, and matrix B has dimensions n by p, notice the last one of A matches the first one of B, then the resulting dimensions are m by p. Okay, so these last two have to match, and then our result is the first one and the last one. Okay, so it says using the matrices to the left, determine if the product is defined. If yes, give the dimensions of the result. All right, so we're not actually multiplying them just yet. We are just seeing if it's defined. So A and D. A is 4 by 3, and D is 3 by 1. Notice these two match each other, so yes, it is defined, and our dimensions would be a 4 by 1, that first one and the last one. Okay. Then we're going to look at A and C. Again, A was 4 by 3. C is 2 by 4. These two do not match, so we would say no, it's not defined. And since it's not defined, we don't need to give dimensions. Okay. This is pretty straightforward. You could go through and you could pause it here, go through and test each of those out and see if you agree and decide. So B is a 1 by 5. E is a 5 by 2. So they match in the middle, so we would say yes, and our result is a 1 by 2. Okay. B again is a 1 by 5. D is a 3 by 1. They don't match in the middle, so we'll say no. I'm going to change colors. C is a 2 by 4. A is a 4 by 3. They match, so this would be a 2 by 3. Okay, we have a 5 by 2, and C is a 2 by 4. They match in the middle, so we would have a 5 by 4. Hopefully we're doing okay so far. Just checking to see if we could even multiply them together. E is a 5 by 2. B is a 1 by 5. So we would say no, because they do not match here in the center. And then lastly, D is a 1 by 3. And B is a, hold on, I wrote that backwards. Silly me. Try that again. D is a 3 by 1, and B is a 1 by 5. So since they match in the middle, we would say yes. And then we would say 3 by 5. Okay? So that's just checking to see if you can even multiply them together. All right? Now let's talk about how you actually complete the multiplication when you can. So it says the elements in the nth row and the nth column of a matrix AB is the sum of the products of the corresponding elements in the rows M of the matrix A and the column N of B. And it shows this pattern below. So we'll write down a cute little formula for it. But what we're looking at here, let's see if this highlighter will work. I want it to be a little thicker. Yeah. Okay, so what I'm looking at here is I'm going to be looking at the first row and first column to start out my multiplication. So when I do this, again, this one is a 2 by 2, and this one is a 2 by 2. So the middles match, which means my last one should be a 2 by 2. Okay. Alright, so when I go to write these, I am multiplying this, as I was saying, this first row times this first column. So this is going to be AE plus BG. Okay. And then I'm going to do that row again, but then times that next. Okay, I'm going to do this row again. Sorry, that row again. But now I'm going to do it times this column. Okay, so for that second one, I'm doing this row times that next column. So when I write this one out, it's going to be AF plus BH. Okay, and then to do the bottom, I'm going to do the second row times the first column, the second row times the second column. So I'm going to do CE plus DG, and then CF plus DH. All right, so we'll take this kind of slow when we do our example, but that is our formula that we're using. All right, so let's try. Okay, I'm going to start with doing my first row and my first column. So I'm going to have this as, I'm not even going to put a bracket yet. I'm going to have this as -4 times 6 plus -9 times -5. Okay, so that's going to be my first element. And then I'm going to have -4 times -1 plus -9 times 4. Okay, once I've done that, I'm going to switch to the next row. So I'm going to have 3 times 6 plus -2 times -5. And then 3 times -1 plus -2 times 4. Okay, and then I'm going to complete each of those multiplications and addition to find my elements. So -4 times 6 plus -9 times -5 would be 21. -4 times -1 plus -9 times 4 would be -32. And then 3 times 6 plus -2 times -5 would be 28. And 3 times negative 1 plus negative 2 times 4 would be negative 11. And this would be my answer. Okay, so then I can look to see, I told you that you can do this in your calculator, so I was going to show you how to do that. Let me grab a calculator real fast. Okay. I'm going to write down this problem so that we can do the same one. Negative 4, 3, negative 9, negative 2, 6, negative 5, negative 1, 4. And if you're wanting these steps, a good place to write them would be right over here in this empty space that you have. Okay, so let's show you how to do this in your calculator. So if I pull up my calculator, I just went ahead and cleared the RAM on it. So I want this one that says matrix that's in blue. So I'm going to hit second matrix. If you look down at the bottom here, it's going to tell you what buttons I was pushing. I'm going to arrow over to this edit one. So edit, and then I'm going to hit enter. And I'm going to type in my first matrix. Now I need the dimensions. My first matrix is a 2 by 2. So 2 by 2. And then I'm just going to fill in what it says. So it was negative 4, negative 9, 3, and negative 2. Okay, and then I'm going to go back, second matrix, arrow over to edit, and this time I want to edit number 2, so I do need to go down to B this time, or select number 2, so that I can put a second matrix in. So this was also a 2 by 2, and it was 6, negative 1, negative 5, and 4. Okay, and then I'm just going to hit second, quit. So I'm on my blank screen. Okay, so I put both of my matrix in there. Now I want to multiply them. So I'm going to hit second matrix, hit enter for A, second matrix, arrow down, and hit enter for B. So this says A times B, and I'm going to hit enter. And notice that gives me the 21, negative 32, 28, negative 11 that we got just a minute ago. Okay, if it gives you an error, more than likely the dimensions didn't match the way they were supposed to. Okay, so you can try, you can use your calculator if you'd like. I suggest going through those other ones. I will give you the answers on them, but you need to at least try them first. So you can either do it by hand or use your calculator. There's a few of them I want to do by hand with you. Number 10 is not one of them, so I'll just go ahead and you should pause it, try putting it in your calculator or doing it by hand, and then double check. Our answer on number 10 should be negative 16, 6, 40, negative 54. Okay. Now we're going to come down to number 11. Number 11 is a 2 by 3 and a 3 by 1. So that means it should end up as a 2 by 1. Okay, so when I do this, I'm going to start by multiplying this top one times my single column here. So when I do that, I'm going to have negative 7 times negative 6 plus 2 times 4 plus, I can't tell if that's a negative or positive 11. Okay, plus negative 11 times negative 3. Okay, so I multiplied that top row by the only column. And then I'm going to go on to the second row times my only column. So that's going to be 3 times negative 6 plus negative 5 times 4 plus negative 2 times negative 3. So notice this does end up going a 2 by 1. So when I actually work those out, I would get 83 and negative 32. Again, you can do this in your calculator. So I'm just writing it down really quickly so I don't have to look back and forth at it. Okay. So if I go back to my calculator to check my answer, I'm going to go to second matrix. I'm going to edit this first one, and ours was a 2 by 3. I didn't take anything out. I'm just going to type on top of it. So negative 7, and it'll just replace it as you type. 2, negative 11, 3, negative 5, negative 2. Okay, and then I'm going to go back, second matrix, and I'm going to edit B. B this time is a 1, clear, sorry, second quit matrix. B, have to go over to edit and then to B. B this time is a 1 by 3. Oh my goodness, that is the second time I've done that. Silly goose. B is a 3 by 1. Ha! I don't know why I did that. Negative 6. 4. Negative 3. Okay. And then I'm going to hit second quit. And you can go back and type it again, or you can just arrow up to this, A times B. And that's still the same thing we got. Okay, so you can use your calculator to help multiply these for you. So I think it would be a good idea to go back through those other ones. I'll tell you what they are, like I'll give you the answer on them, but you should probably pause it here, try them with your group, see if y'all are getting the same things, especially if you're going to do them by hand, because there's some things that we could easily mess up on there. So I'll give you the answers though, so if you want to pause it and then come back and look. Alright, so this one should be a 1 by 4. It should be 22, 76, negative 48, and then positive 42. On 13, you should end up with a 2 by 3. And your 2 by 3 should be negative 22, 152, negative 55, 2, negative 54, and 18. 14, you have a 3 by 1 and a 1 by 3, and we're going to end up with a 3 by 3. So this would be negative 14, 126, 70, 2, negative 18, negative 10, 6, negative 54, negative 30. Okay, on 15, 15 is a 2 by 3 and then a 3 by 2. So you should end up with a 2 by 2. Okay, so this 2 by 2 looks like 10, negative 69, 30, and 52. And then on 16, we have a 1 by 2 and a 2 by 1, which means we should end up with a 1 by 1, which is just a singular element, and it's negative 107. Okay. Okay, it says given matrix A and B to the left, find AB and BA. What can you conclude? All right, so I'm going to do AB first. You can either multiply by hand or use your calculator. When you do A times B, you should end up with negative 13, 48, 24, 88. Okay, so if you didn't pause it, double check that multiplication, make sure you get the same thing, and then do B times A. Again, you can use your calculator or you can do it by hand, but multiply B times A and then double check to make sure we're getting the same things here. On B times A, you should get 34, 82, 45, 41. And then notice that these are not the same thing. None of the elements are actually equivalent to the corresponding element. So it says, what can you conclude? Well, normally with multiplication, when we're multiplying real numbers, we can multiply in either order. That's called the commutative property. But notice here that when we change the order, it does change our answer. So the big takeaway here is that the commutative property doesn't work for matrix multiplication. My U and my L got stuck together there. Okay, so commutative property does not work for matrix multiplication. You cannot multiply in any order. You have to do it in the order that it's given. Okay, so the last thing we're going to talk about before doing some applications is the properties that do work. So we do have the associative property, which is still just fine. Associative talking about how things are grouped together. So if I have A times B times C, I can still regroup that as A times and do the B times C first. Okay. We still have associative property for a scalar, so if I have a scalar times A times B, I can multiply the scalar and A first and then multiply by B. That one's fine too. I have a left distributive property. Now notice that this says left and not just distributive property because we can't multiply in any order. We do have to make sure that we do left and then right. So if I have C times A plus B, that's going to be CA plus CB. Okay, and then if I want to go the other, I have to rewrite. So that's changing the order. Okay, if I have A plus B times C, that's going to be AC plus BC. And those do not have to be the same thing for matrix multiplication. Most of the time they're different. Very unlikely that they would be the same. Okay, so it says the first table shows the number of reams of paper, packs of dry erase markers, and boxes of staples requested by 2 teachers. The cost per item is given in the second table. Use matrix multiplication to show the cost of supplies. Okay, well, it's giving you your 2 matrices right here. This one's your first matrice, and this one's your second matrice. Okay, and what we're doing is we're just multiplying those 2 matrices. So you can rewrite it if you want. You don't have to, but maybe if you want to know what you did when you go look back at your notes. So I'm multiplying by this other one. And again, you can either use your calculator or you can do it by hand. Either way. Okay, when I multiply these, it's going to give me, it says use matrix multiplication to show the total cost of supplies for each teacher. So my first number is 118.50, and I'm going to put the 0 since it's money, and 135.50. And again, I'm going to put the 0 because it's money. This first one is the Smith, and the second one is Will's. Okay, so Mr. Smith's total is the top one, Miss Will's is the bottom. Okay, so again, it says the students of Oakland High School are selling bags of popcorn for 10, tubs of cookie dough for 12, and buckets of fruit for 16. Sorry, the number of each item sold per class is shown below. If they earn 15% profit on each item they sell, use matrix multiplication to show the profit earned for each class. Give your answer as a matrix. Okay, so this is our first matrix, this one right here. This is our first matrix. It's already done for us, nice, neat, and pretty. So if you want to copy that one down here. Oh, I'm writing too big. Uh-oh. Gotta finish this one up fast. 28, 18, 32. And then let's talk about what that second matrix is going to look like. That second matrix says we want 15% profit. That would be 0.15 of what we're selling them for. So 0.15 times 10 is going to be 1.5. 0.15 times 12 is going to be 1.8. And you can put the 0 because it's money. And then 0.15 times 16, which is 240. Okay, then use your calculator or do it by hand, whichever one you want, to find your totals. And it's going to go in the order it was here, freshmen, sophomore, junior, seniors. So 349.20, 284.10, 216.60, and then 297.90. Okay. So, which class earned the most profit? So which one has the highest value? That looks like your freshman. Okay. Give the total profit for the school. So to find the total profit, we would add up everything together. So if we add those all together, we would get 1147.80. And then how much more profit did the seniors earn than the juniors? Okay, so we're going to do our seniors total minus our juniors total. So seniors minus juniors would be 81.30. Okay, and it looks like that is it for multiplication. So you do have an assignment that goes with this. I know this was a longer video, but hopefully you'll have a little bit of time today or tomorrow to work on that assignment. And if you have any questions, you're always more than welcome to email me. I hope you'll have a great rest of your day. Bye.